Meredith here with Global Systems Science, Global Climate Change Unit, Investigation 2.3, Why do some molecules absorb infrared energy? Now, prior to starting this investigation, students have read about the electromagnetic spectrum, and they understand that infrared energy is part of just a long range of EM radiation, going from radio waves and infrared energy all the way up to X-rays and gamma rays. And visible light that we use to see is right in the middle. Now, in this investigation, we want to understand why some molecules resonate or respond to and absorb infrared energy and why others don't. And to do that, it's very helpful for students to create models. In the previous video, I showed you how to create these models. So in brief, we take two 15-centimeter lengths of pipe cleaners. If we twist them 4 times, and then cut them into various lengths depending on whether we're trying to represent weak bonds or strong bonds, and insert them into high density styrofoam balls, we will end up with molecules that respond differently to different inputs of energy. And in this case, we are going to use our energy from our hand, the amount of shaking we do, increase or decrease of energy there, as standing in for different kinds of electromagnetic radiation. So let's see how this works. When you get this done, you'll have 4 different molecules built. You have methane, which if we give it a shake, starts to vibrate at a fairly low energy level. And we're going to count the number of shakes in a certain period of time and record that. We also have carbon dioxide, and this one, instead of having a single weak bond, has a double long bond and of the same length. And when we do that, we're going to again hold it in the center, and when we get it going, we are going to have a certain resonance, which we can count. And you can even see just by looking at my hand that I'm having to put more energy in, faster movement of my hand, that represents more energy, in order to get that to resonate. But it's still fairly low. Now, when we get to the oxygen and the nitrogen molecules, we have a short bond, and we have 2 for the oxygen, because we have 2 oxygen atoms bonded together, because they like to hang out in pairs, and 2 nitrogens bonded, but there's 3 here. Might be a little difficult to see, but there are 3 here. And these are the same length of bond. Now, I recommend again that you find the center of gravity by just pushing your fingers together and then pinching it off right in the middle, because this will make a big difference on whether students are able to feel a vibration or not. When you get started, you have to shake it pretty fast to get any kind of feeling of resonance in here. And this might not be anything that you can see, but the students will definitely be able to feel the point at which they reach resonance in O2. And I would make sure you try this out beforehand, because you'll be balancing out the length of your pipe cleaners with just how much density you manage to get into your styrofoam balls. And then again, when you get up to the nitrogen molecules, you can shake and shake all day, and if you've got a good grip on that, you are not going to feel any resonance whatsoever in that molecule. So good luck and have fun investigating resonance of molecules in our atmosphere and their response to infrared energy.